Class 12. Today we will talk about example 1.12. In this question it is asked that an electric field is given which is uniform along positive x-axis and magnitude but negative along negative direction. The value is it is given that electric field E is equal to 200 Newton per Coulomb for x is equal to x greater than 0 and E is equal to minus 200 Newton or 200 I. It is a vector quantity, means I is a unit vector along positive x-axis, and E is equal to minus 200 I Newton per Coulomb for x less than 0. A right circular cylinder of length 20 centimeter and radius 5 centimeter has its center at the origin and its axis along the x-axis, so that one face is at x is equal to 10 plus 10 centimeter and other face is at minus 10 centimeter per second. Then we have to find first what is the net outward flux through each face, flat face of the cylinder, what is the flux through the side of the cylinder, and thirdly what is the net outward flux through the cylinder, and lastly what is the net charge inside the cylinder. We know that flux is equal to E dot ds, means the electric field is given 200 and the delta S is the area of the flat surface. Then since it is given that the length of the cylinder is 20 centimeter and the radius is 5 centimeter, so therefore we have 5 centimeter converted into meter, and then we get pi r square gives us the area of the flat surface, so it becomes 200, that is electric field. And since it is along positive axis, therefore E dot ds will have the value E magnitude into S magnitude, delta S magnitude. Therefore it becomes 200 into pi r square, r is 0.05 and that comes out to be 1.57 Newton meter square per Coulomb. That is the total electric flux passing through one face. And on the right face, E and S, delta S are parallel, and therefore we have again phi E on the right face. That was the previously we have calculated the phi E on the left face, and we are calculating now phi E on the right face. That is equal to again 1.57 Newton meter square per Coulomb square. So this is the total. Now for any point on the side of the cylinder, E electric field E is perpendicular to the surface, therefore curved surface, therefore E dot ds for the curved surface is 0, and therefore the flux out of the side of the cylinder is always 0. So now thirdly, the net outward flux through the cylinder is 1.57 plus 1.57 plus 0. The 0 represents the flux through the curved surface, and therefore the 1.57 plus 1.57 becomes 3.14 Newton meter square per Coulomb. That is the total electric flux coming out of the cylinder. Now we have to find the net charge inside the cylinder, due to which there is some net outward flux. And so we know from the Gauss law that Q is equal to epsilon times phi, because you know phi, net outward flux phi is equal to 1 by epsilon times the charge enclosed, and from that we derive this relation Q is equal to epsilon into phi. Electric flux phi is electric flux. So now you see that value of epsilon is 3.14 into 10 to the power into 8 into 3.14 was the total electric flux, so that is the value of flux going out, into value of epsilon, that is 8.85 into 10 to the power minus 12 coulomb. So that together becomes equal to 2.78 into 10 to the power minus 11 coulomb. That's all for today. Thank you and have a nice day.